Good day guys, you're welcome to easylearn.ng. Today on chemistry class, we are treating kinetic theory of matter and gas law. And this is actually a series. It is splitted. The whole topic is split into 4 parts, and this is the first part. So do well to follow through to all the contents of this lecture. And for today, this will be our outline, the outline of today's lesson. We're going to talk about the introduction to kinetic theory of gas, look at the postulates of the kinetic theory of gas, and we will also look at the characteristics, properties of gas. Those are the volume, pressure, temperature, standard temperature and pressure. We'll look at the mole of a gas. Without wasting much time, we'll start. And what's the essence of the kinetic theory of gas? Okay. Kinetic theory of gas explains the behavior of gas. It actually explains the physical behavior of gases. It describes the behavior of gas. It also explains the type of attraction that occurs between the molecules of gas. It explains the type of collision that exists between the molecules of gas and the container. Gas is in a state of constant motion because the molecules are always moving. And that type of motion is random and irregular motion. We're going to look at the type of collision that exists between the gas molecules and the walls of their container. This is explained by the kinetic theory of gas. Another thing it does is that it tells us the factor that affect the kinetic energy of gas molecules. Of course, you know what kinetic energy is, the energy due to motion. So we want to look at that important factor that determines the rate of kinetic energy, the rate of motion of gas. Right. And let's look at the postulate of kinetic theory of gas. The first postulate states that a gas is composed of large number of identical molecules moving at different speed. Alright. A gas moves randomly. A gas is always moving, colliding with one another, and the molecules of gas are actually identical. They move at different speed, colliding with one another irregularly and with the walls of their container. So the speed of the various molecules differ widely and are constantly changing. Another postulate is that the space occupied by the gas is negligible compared to the volume they occupy. As you can imagine, you cannot actually feel the mass occupied by a gas. Why? Because the space is negligible, is insignificant. We cannot see it. We cannot feel the presence of the gas. We can actually feel it, but we don't see it. So that space occupied by it is negligible compared to the volume they occupy. Another postulate of the kinetic theory of gas is that the force of attraction between the gas molecules are negligible. That means it is insignificant. There is no strong force of attraction. There is a weak force of attraction between the gas molecule. The gas are independent of each other. And you see, I said the force of attraction, I put in brackets the coercive force. What does coercive force refers to? Coercive force actually refers to the force of attraction between molecules of the same type. Force of attraction between molecules of the same type. So the coercive force that exists between gas molecule is negligible. It's so small, right? Another important postulate of the kinetic theory of gas is that the collision between the gas molecule and the walls of the container is elastic. Now, what does elastic collision means? Elastic collision is a type of collision in which no kinetic energy is lost. This means for the fact that gas molecules collide with the walls of their container does not affect their kinetic energy. The kinetic energy remains intact. The kinetic energy after the collision and before the collision is the same. There is no loss in kinetic energy. That is what elastic collision means. And the last but not the least postulate of kinetic theory of gas we have here is that the temperature of gas is a measure of the average kinetic energy. Okay, this is one of the most important postulates of kinetic theory of gas you have to know as a student. The temperature determines the average kinetic energy. The temperature is directly proportional to the average kinetic energy. This means that the higher the temperature, the higher the kinetic energy. You can picture this when you are boiling the water and when the steams are coming out. You find out that the higher the temperature goes, the faster the rate at which the steams are liberated. The gas vapor are liberated. This is to say, the higher the temperature of gas, the faster they move. That is what is explained in this postulate of gas theory of gas, kinetic theory of gas. Let's look at the characteristics, properties of gas. Let's look at the characteristics, properties of gas, and the first one we've been talking about is volume of a gas. The volume of a gas is the space accessible to it, the space it occupies, and it has various units. We have centimeter cube. It can be in centimeter cube. It can be in dm cube, decimeter cube, milliliter, or liters. Alright, and here you have some conversion rates. 1000 centimeter cube, sorry for this is 1000 centimeter cube equals 1 liter. Is actually approximate to 1 liter. 1 decimeter cube is approximate to 1 liters. 1000, I made a mistake here. 1000 centimeter cube equals 1 decimeter cube, and 1000 milliliter equals 1 liter. Please try to take note of this conversion rate because you'll be needing it when we start calculations involving gases. For instance, now if I ask you to convert 50 centimeter cube to convert it to liters, sorry, convert it to cm cube, convert it to meter cube, how do you do that? You just say, recall that 1000 centimeter cube plus 1 decimeter cube. So how many cm cube will make 50? Just apply here. 1000 times 50, that's 50,000. X times 1 is x. So then if 1000 centimeter cube equals 1 dm cube, then 50,000 centimeter cube equals to 50 cube. Let me just give you a clue. When you are converting from dm cube to c cube, by that value by 1000. Know this. Or if it is from cm cube, you are converting from cm cube to dm cube. You divide that unit by 1000. This is very fast to convert values. Note that very well. When we start calculations, you are going to need it. Another properties of gas is pressure. Alright, gas pressure is the combined force with which the gas molecule bombard the unit area of the wall of the container. Okay, each time the gaseous particle hits or collides with the wall of the vessel, it actually exerts a small force on it, and that's what we refer to as the pressure. That's what we refer to as the pressure. You know, the gas molecules are actually numerous, and they will fill the container. They are evenly distributed in whatever container you put them in. So there is a collision that exerts a constant force on the walls of the container. That force per unit area of the wall of the container is what we refer to as the pressure of the gas. That is the pressure of the gas. Gaseous pressure is commonly measured in, we have the units there. We have millimeters of mercury, we have atmosphere, we have torr, we have pascals, we have newton per meter square, and these are the conversion range. Note them very well, you need them. The next important properties of gas we'll be talking about is temperature of the gas, symbolized by T. The volume is symbolized by V. Pressure is symbolized by P. Right? What's the temperature of the gas? It's the measure of the average kinetic energy of the molecules of a sample of gas. If you remember, in the postulates of the kinetic theory of gas, we've already mentioned this. What are the various units of temperature? Celsius, Fahrenheit, and Kelvin. Right here, you were told that Kelvin scale, or the absolute scale, is the standard scale of measurements in calculations involving gas. That means mostly you'll be required to convert any units that you are given to Kelvin. If you are giving your temperature in degrees Celsius or in Fahrenheit, you'll be required to convert it to Kelvin. How do you do that? When you're converting from Celsius to Kelvin, most especially, just multiply the value, you just add the value with 273. Standard temperature of gas, STP. This gives the value for the standard temperature and the standard pressure to which gas molecule can be referred to. In most cases, in calculations involving gas, you might just be told that a particular gas is at STP. That means the value of the temperature and gas, the value for the temperature and the pressure of the gas are this. There is a chosen value for STP, okay, and this is it. 1 atmospheric pressure, or 760 millimeter mercury, and the temperature is 0 degrees Celsius and 273 Kelvin. Any gas at STP will have these values of pressure and temperature. Next, we're moving to the mole. What does mole refer to? Although this is not a comprehensive explanation of mole, we're going to make another videos on mole. But what is mole? Mole is the quantity, mass, or volume of a gas that contains the Avogadro's number of molecules. This value right here is the Avogadro's constant. Call this number the Avogadro's constant. 1 mole of any substance occupies 6.02 times 10 to the power of 23 molecules. One of these days we are going to make a video on mole. I'm going to explain the concept of mole. The concept of mole is a very, very, very important concept in calculation involving physical chemistry. So this implies that 1 mole of any substance, right here we are talking about gas, so 1 mole of any gas contains 6.02 times 10 to the power of 23 molecules. It might be atoms, any elementary particles. It might be molecules, it might be atoms, it might be ions, protons, and so on and so forth. And it also occupies a volume of 22.4 dm cube, or 22.4 liters at STP. Right, thank you for watching. This is where we're going to stop it for the first part of kinetic theory and gas law. Do well to follow through. Stay tuned as we release the next parts. Subscribe to our YouTube channel, like and follow our Facebook page, follow us on Instagram at easylearn.ng. On YouTube we are easylearn_ng. Please subscribe to our channel. Also click on the notification button to get notified when we drop new content. If you have any question you want to ask on this topic, or any idea or suggestion, please do well to drop it in the comment section. We look forward to your feedbacks, to get feedbacks from you. Thank you very much for watching. On our next topic, we'll be talking about the second part of this class. We'll be talking about the gas laws and related problems, where we'll be talking about the Boyle's law, Charles law, and the general gas equation. Thank you very much. God bless you.